Hello, welcome back to Parser Hacking. We are continuing our work on the recursive descent parser. And when we left off last time working on this, we had numbers and operators parsing, and empty program and basic strings were parsing. But there's a few tests commented out here that I want to see if I can get working. The first one will be this one. It has a new line after the plus sign. And if I run this test, I get a panic unreachable, and that is right here because we don't know what to do when we are not consuming the new line token, which is in our Lexer. There's it's called EOL, end of line. And so it's something we need to consume somewhere. The question is, where? Where do we consume this? So it's going to be in our parse infix expression, I believe. I think, because it comes into this one with the one already parsed, and then we get the operator and we advance the cursor. Oh, and then we call parse expression again, which doesn't know what to do with the new line. So I think we can be safe to, at the top of parse expression, just consume any new lines. We can't consume semicolons because that is quite different. So if we had this with a semicolon in the middle, that is quite different. So I'm glad that I made this a separate token because I have a semicolon down here. So we can do the right thing, hopefully. And I think that what we want to do is just skip white space, and we'll make a new private member function for that. Well, it's not skip white space because white space is already tokenized. Let's rename this to, actually, let's not even make a method. We'll just do it this way. So while current token is EOL, I'd like to have a little convenience method for that. So is EOF, we'll have an is EOL. So while this is an end of line, then we just want to advance the cursor. And let's see if that fixes that one test. And it does. This is great. So we're going to add that. I'm going to say skip white space, or skip new lines at the beginning of an expression. Okay, so parser test. We're going to go back here. Let's go down the line here. Let's see if we can get all of the rest of these working. Maybe even this one. Yeah, so we have string parsing. That one may actually work. I'm just out of curiosity. Let's see if it does already work. It does. That's even better. So the only ones we need to do are these grouped expressions, which I showed 2 videos ago, how to do grouped expressions with a prat parser, and this is so cool. Let's see if I can even remember how this works. But wherever our token lookup, wait, how do we do that? I've already forgotten. Parse, null denotation and left denotation. No. Precedence, get precedence. Yes. That was the method. Fascinating. Get precedence looks up the Oh, that's right. So the parens, we treat it as a left denotation, or sorry, a null denotation. So if we see the L paren, then we want to do parse grouped expression, which we don't have yet, but we will make. And it's going to advance the cursor to advance past the paren. And then we're going to store an expression here. And we're going to do parse expression env, and we're going to pass lowest here. I think I should probably prefix these because I believe these are in the global namespace, but I'll get back to that. What am I doing? What am I doing? It's just env. Silly me. And we're going to say if, let's see, what if parse expression, yeah, it's going to do its thing. So let's say, what if current token, if it's not valid, then we're going to I don't know. For now, I'm just going to do a printf because I'm not sure how I want to handle this. I want this to raise. Yeah, I want this to raise. I do. I want it to raise an exception. What does Ruby do? If I do Ruby E, just an open parens, syntax error. Is that something you can rescue? It's not. Well, then we don't want to raise an exception. Maybe we do want fprintf. Expected closing parens, but got EOF. Abort. And then let's say else if current token dot type is not equal to elixir token type r paren. Then we're going to do something similar here, but got, what did we get? What did we get? Current token to, what did I call that? Go up here to Ruby. And that's long type value. That's what I call it. Type value is going to be a symbol as, I should have just made this a symbol value. Oh, but it can be nil. Okay, that's why. So we're going to say, we'll just inspect it. Does that work? Well, it's not happy about something. Type value. Oh, we need to pass in the environment. Now, are you happy? Okay, and then we return the expression. So does that parse grouped expressions? It won't parse these new lines, I'm pretty sure, but it might do the rest. Nope, panic unreachable. Now, it'd be really nice if I could tell what line number that was on. It is in get precedence 135. Okay, so fprintf standard error got token. I don't know how to handle %s. Do something similar here where we say, oh boy. I'm just going to turn this. Oh, can I do that? I just want something usable for debugging right now. Yeah, that's what I was afraid of. But I can cast this, just a stupid cast. I just want some data. Got token, I don't know how to handle 59. Well, does that really help me? Now do I have to count these? So I think it'd be on line 41-ish. Oh, was there an equal in there? No, there's not. There's just... Well, I'm not sure what I'm looking at. 59. Oh, I should have added. Yeah. 59 plus 18 is 77. That's the token that it's confused about. I really got to find a way to do the right thing here. R paren. It did not know what to do with R paren? Interesting. And what was get precedence being called from? Parse expression. Parse infix expression. Parse expression. Oh. And it was R paren. Oh, look at this. Okay, so right here, I assume that's what line number it's on. Line 178. Yeah, that'd be about here. We get the precedence of the next token, but that should be a number. Something went wrong. Okay, let's back up. We parse a grouped expression. Actually, let's just get a fresh. And while we're here, let's make this a little easier on ourselves. We're going to change get precedence to take a token so that we can print it out when it is it's not something that we expected. So we're going to say token inspect, nope, to type value env inspect env. A little bit verbose. And this is a dot, I believe, and we don't have an environment. Well, just going to pass it in because that's the way I roll. Okay, so now, why can't we build now? You have to pass that in. Okay, 147. This is not supposed to be here. Now you're happy. Okay, let's get a good trace back, and yeah, now we can say got token, I don't know how to handle right paren. That's much easier to understand. So we're in the parse grouped expression on 189. So let's go look at 189. Was I not supposed to advance the cursor? I believe I was. Yeah, because we get the null denotation here. We call it here. Yeah, we have to advance the cursor. Makes sense. To get past the left paren. And then we're going to parse the expression, which in our case is 1 plus 2. Okay, so let's see if that works here. let's go to frame 5. Oh, come on, frame 5, and print the current. Oh, print the current token. The current token's a right paren at frame 5. Does that even sound right? Looking at the book to see if I did something wrong. I think I did it right. Yeah, I'm a little bit puzzled here, obviously. Parser HPP 189. Okay, so let's go to frame 6. Let's back up a little bit. Oops. Frame 6, what is our current token? Oh, right. Okay, we need to do some printf debugging. I'm looking at the data. It's already been changed, so yeah. So let's do this. Printf token equals token. Say current token to Ruby inspect. A little debug script for this, or a little debug function for this would be nice. Let's just see what the token is there. I suppose I could set a breakpoint, but I don't know. I'm a printf debugger. Okay, so that is what we expected. It's a literal 1. And then we call parse expression, which we don't get this far, I believe. I believe it's not even going to say token equals. Yeah. Okay, so we don't get that far. We get into parse expression, which goes down here. And let's just validate our theory on this one. So it should print twice, I believe. No, it should just print once. Oh, well, it doesn't help that I'm running a whole bunch of code. Let's do it this way. Let's just run just the line of code that we want. I'm not sure why I did that. That's kind of weird. Okay. So it got a left paren, and then it got a 1, and then it got a 2. So the left paren was the lefty notation. And then it recursively called parse expression again, and it parsed the 1 with a null denotation. And while the token is valid and the precedence is less than get precedence for the current token. So how many times did this get called? We're just going to do something stupid here. I'm going to say, yo. Just once. I guess that makes sense. It worked in Ruby because it was returning a null or something like that. So I guess that we should make one. Now, how did they get away with not having to do that in the book? That's fascinating. Does it always return the lowest as like a, let's see if I can find the part in the book. Maybe the default value returned is lowest. That would make a little bit of sense. That's it. That's exactly what it does. It always returns lowest if it can't find one. Okay, This is the problem. We don't need this. We need to return lowest. I'm glad I found that. Okay. So does this work? It works. I think. Well, it didn't quite work, did it? It got the 1 plus 2, but it didn't get the times 3. So let's run our test again. And to confirm. Yeah, fascinating. So it got the first part, but it didn't get the times 3. What went wrong there? What went wrong? Could it be that I'm only parsing a single expression here? What is my token here? Let's see. I already have something I stole earlier. Just put that there. Run this. What is my current token afterwards? It's a closing paren. So it didn't consume the next thing. Now why is that? Why didn't parse expression keep going? Because it could have parsed this as a left denotation and then added the times 3. It should have. Okay, so there's a problem there. So this thing here is not going to be true. Let me just go through this again. We call null denotation. We see an L paren token. We return the parse grouped expression function. We call the parse grouped expression function, which recursively calls parse expression and consumes all the way up to here. But it doesn't advance the token. I think that is the problem. So we need to advance it. Okay. Well, I'm tempted to cut out some of this pain, but I'm going to leave it in to show that this is just normal. This is just part of learning how to do this stuff. And I think if I did this every day, I'd probably get a little bit faster at recognizing what I'm doing wrong. I should have walked through this function logically instead of just trying to look at the book and write it. And it's not the book's fault. It was my fault because of the way I did it. I named things and did how I advanced the cursor. I did it differently than the book. So that kind of bit me here. But all's well that ends well, and at least in parser hacking. So let's see what it'll take to make this one work. I think there's gonna have to be something. Not sure what it's gonna be. Probably gonna have to consume white space somewhere. Expected parens, but got a new line. Okay, so why don't we just do the same thing here that we did up here? Should I make this a little helper? Why not? Skip new lines. And we'll put this way down here. It's kind of just a little nothing. Skip new lines. And so we use it here. And we're also going to use it right after we parse this expression. We're going to skip some new lines. And hopefully that will fix this test. Yes. Well. Look at that. We now know how to parse grouped expressions, and we know how to do new lines in the middle of an expression. Nice. I'd say that's pretty good. Let's commit that. Parse grouped expressions. Oh, that's awesome. Okay. I'm gonna decide real quick if I want to do one more thing. What about parse multiple expressions? What if we, oops. What if we, I don't think that'll be too hard. Okay, so it looks like it got the first one, 1 plus 2, but it didn't get the 3 plus 4. And I think I know exactly where that needs to be fixed. That's in the tree method where we don't do any looping at all. We create a block node. So let's change this into a while. While the current token is valid. You know, I'm now doubting myself. What does is valid mean? I just have invalid. I have EOF. Interesting. This is not really the right condition. It should be while we're not at the end of the file, then we're going to parse the expression and add it to the tree. But we also want to check if it's invalid. If current token is not valid, we need a little not on here, then printf invalid token. I'm just going to do it this way for now because I'm not sure exactly. Well, I don't even know. It's just an invalid token. I'm just going to do that. Abort. And then also put it inside of here. Oh, that's a little bit gross. In fact, that's quite a bit gross. I don't like that. I'm going to leave it for now because I need to do some investigation of what are the code paths that produce an invalid token. Well, let's just look real quick. The default token type is invalid. Does invalid just mean nothing? Oh, no. It can mean something that's just unrecognized. And we may want to show what it is. Okay. So we can call type value and we'll raise an exception. I don't think that's actually correct either because we saw earlier Ruby doesn't raise an error on a syntax error, not when it's parsing a file, but okay, we'll worry about that later. Yeah, for now, I'm going to do this. So what if we said current token literal, which is a string, and we print that. At least that will be helpful. So if we see an invalid token, we'll print something and we'll abort. And I think that will be good for now. So let's see if our multiple expressions work. Nope. Invalid token null. Invalid token null. Where do we produce the end of file? Oh, we don't actually return the end of file token, but we should. Okay, so let's change the order of these. Let's go ahead and push the end of file token because that's pretty handy. So now we should have access to the end of file token. Yes. So what we did, we changed our lexer so that now we actually put the end of file token on the end of the stream of tokens. So we have something to look at in our parser. And the parser does a little bit of gross code here to see if there's an invalid token, and if it does, then it just prints it to standard error and aborts. And the other change was we did a while loop here, so as long as we're not at the end of file token, then we're going to keep parsing expressions, and we're going to add them to the tree, and of course we return the tree, and so now we can have multiple expressions. Parse multiple expressions. Well, let's push that, and let's just do a little inventory here, see what's maybe on the docket for next time. Parse method calls with parentheses, without parentheses. Oh, I might as well, while I'm here, do this one with a semicolon, because that one's going to fail as well, because it's not a new line. I believe when an expression is finished, so there's a subtle difference between a new line and a semicolon. So if I have foo, let's see, I have 1 plus 2 and I have -3, like that. That's a new line, and those are two different expressions. But if I have 1 plus 2 semicolon -3, those are two different expressions. So you would think, okay, those are the same. We should treat semicolons and new lines the same. But that's not exactly accurate either, because if we have 1 plus 2 like this, that's not the same as semicolon 2. I should probably just verify that. I should probably just verify that I'm not talking out the wrong end of myself. Oh my goodness, what have I done? Okay, I know how that works. And I know how this works. I don't even need to see that. That's pretty obvious. X equals this, Y equals this. Let's print X and let's print Y. Unexpected semicolon. Yeah, so it's definitely not the same. But I think we can do it at the end of parse expression. I think we can say, where do we think the unreachable is coming from? It has to be coming from here, the null denotation. It's definitely not a null denotation. Well, that makes me think that possibly we could skip the semicolon, or we could return early here. No, I need to do it before this is called. Okay, instead of just guessing, let's run this, but we're going to change it to be 1 plus 2, 3 plus 4. Okay, 1 plus 2, 3 plus 4, then we're going to run it through GDB. And we're going to see where that abort happened. It happened in null denotation, which was called, yeah, so it got a semicolon from parser 221, which, oh, that's here, right? It was called from parse expression, which is on 142. Yes. Which was called from parser was called from parser 159 from the tree method. Parse expression. Well, for now, I don't know if this is right, but for now, to make this particular test pass, I'm going to, after we do parse an expression and add it to the tree, I'm going to skip semicolons. And like I said, I think that's probably wrong, but I feel like I can only write code as good as my tests. And right now my tests are pretty limited to this. I don't know. That's, you know, it's not a great excuse because it's still my fault either way. But is newline is EOL. But in any case, that's what I'm going with. That's my story, and I'm sticking to it. Semicolon. So I believe that'll fix that test. Hopefully, if I did it right. Yeah, it did. Okay, so we're going to just amend that commit and put it all in one thing. I'm going to write a little note. Not sure about how we're handling semicolons, but it gets our very limited test to pass for now. So we're going to say that, I think that's good. Push. Cool thing about working on a project by yourself is you can force push to master and nobody cares. Okay, well, definitely a little bit sleepier video tonight and me fumbling around, but I'm going to leave in the mistakes and try to dispel this myth that people who are successful in coding jobs and programming know what the heck they're doing half the time, which is not true. We Google stuff, we make mistakes, we look at the same page in the same book over and over again. It just happens, and people pay me money for this sort of thing. So yeah, that's just normal. And I'm going to leave it in there to show that that's what it's like. But we got it working. I think that's what's important. I think the most important thing is just not giving up. And I think it's all, the other takeaway is to learn to trust your tests. And the reason I couldn't come up with a better better code to handle semicolons is because I only have one test for semicolons. I think I need to come up with some more and start throwing in some in random places and see what breaks, because it's going to break. But in any case, this is the video for tonight. Thank you for hanging out with me. Hope to do some more parser programming tomorrow, and we're just going to keep banging on it. So appreciate you. Thank you very much. I'll see you next time.